All right, so now we're done covering distance and displacement for 11.1. Let's talk about 11.2 on speed and velocity. So the definition of speed is the ratio of distance an object moves to the amount of time the object moves. Okay, so what this means is that speed is essentially equal to distance divided by time. A couple of things to note is that distance we can measure in meters or things like kilometers in when we're talking about speed and velocity. And time we can measure in units like seconds or minutes or even hours. It really depends on the problem that we're looking at. But the SI unit or the standard unit for speed is meters per second. So distance is usually going to be in meters and time will usually be in seconds since we want to measure meters per second or m/s when we measure speed. But we could also measure kilometers per hour or other units as long as they're a distance over time, since that's what speed is. So the definition of average speed is the total distance traveled divided by the total time it takes to travel that distance. So whenever we want to calculate average speed, all we have to do is take the total distance of the trip divided by the total time it took to do the trip, and then that will give us our average of our speed. This is different than instantaneous speed, which is your speed at a set point in a trip or in that instant. So, we'll practice math some more on another day, but some sample problems. While traveling on vacation, you measured the times and distances you traveled. You traveled 35 kilometers in 0.4 hours, followed by 53 kilometers in 0.6 hours. What is your average speed? Okay, well, we said that speed by definition is the total distance you traveled divided by the total time. So all we have to do is pair our distances together, pair our time together, and then divide them. So our total distance, we would do 35 kilometers plus 53 kilometers to get a total of 88 kilometers. Our total time, we would do 0.4 hours plus 0.6 hours to get a total time of 1 hour. After that, speed is equal to distance over time. So we can do 88 kilometers divided by 1 hour. This gives us a speed of 88 kilometers per hour. Here are some other sample problems. A person jogs 4 kilometers in 32 minutes, then 2 kilometers in 22 minutes, and then finally 1 kilometer in 16 minutes. What is the jogger's average speed? Same thing, just combine your like terms and then divide. So speed is equal to distance over time. So just first add up your distances. You have 4 kilometers, 2 kilometers, and 1 kilometer for a total of 7 kilometers. Then add up your times, 32 minutes, 22 minutes, and 16 minutes for a total of 70 minutes. And then divide your distance over time. Now it's important to note that you always want to do distance over time. Don't just do the larger number over the smaller number because it looks like it makes more sense. So don't do 70 over 7 because 70 is your time, 7 is your distance. So your distance over time would be 7 divided by 70, which would give you a total of 0.1 kilometers per minute. If we look at one more scenario, a train travels 190 kilometers in 3 hours, then 120 kilometers in 2 hours. Again, what is its average speed? Again, we combine like terms. 130 kilometers plus 120 gives us a total of 310 kilometers. 3 hours plus 2 hours gives us a total of 5 hours. We do distance over time, 310 divided by 5 to get a total of 62 kilometers per hour. Your units for speed are always going to be your distance divided by your time. So here would be kilometers per minute. Here it's kilometers per hour. Now, as I mentioned on a previous slide, there's something different than average speed. It's called instantaneous speed. And this would be your speed at a particular instant. So if you're driving and you look at the speedometer, the speed that pops up, that's your instantaneous speed. It's the speed in that instant. It's the rate at which an object is moving at a given moment in time. Okay. It's different than the average speed, which is the average that you went during the trip. If we want graph motion, the slope of the line on the distance and time graph is the speed. So the steeper the slope, the more radical the speed, right? So right here, the speed isn't changing at all, but here it's changing rapidly. So I mentioned the steeper the slope, the faster the speed. Straight lines represent constant speed. So right here, this is a constant speed. These are faster speeds here. And as you can see here, this is the steepest line. This is the fastest speed. Bit slower, bit slower. One other term we talk about in this chapter, or this section, I should say, is velocity. Velocity is essentially the same as speed, but just adding direction to it. So velocity is a description of both speed and direction. So it's considered a vector, as we mentioned in distance and displacement. So velocity is simply by definition speed with direction. Now the difference here is that speed, the number has to change in order for the speed to change. But since velocity is both speed and direction, a change in velocity can result in a change in speed, a change in direction, or both. So for instance, if you're going 70 kilometers an hour northeast and you keep that speed and you change 70 kilometers just east, your speed won't change because it's 70 and 70, but your velocity still would since the direction changed. We want to combine velocities. It's similar to what we talked about in 11.1. If your vectors are going the same way, you add them. If they're going opposite directions, you subtract them. So if this is going 100 kilometers an hour south, the wind is also going 25 kilometers south. It's a total of 125 kilometers south. But if the plane is going 100 kilometers an hour south and the wind is going 25 kilometers an hour north, then the resultant velocity would be only 75 kilometers per hour, since you would subtract them here instead of add them, since the vectors would be going opposite directions, similar to like we talked about in distance and displacement. Some things to think about at the end of this section. What does velocity describe? What shows the speed on a distance and time graph? What's the difference between average and instantaneous speed? How can two or more velocities be combined? Does a car speedometer show instantaneous speed, average speed, or velocity? Explain how. And then a calculation here of how to calculate a plane's average speed between two cities, which it shows you on here. Okay, but again, we'll be doing more math practice with this later on as we progress through this chapter. So don't worry about that too much right now. It's important now just to understand these concepts.